I gotta say that this section 4.4, it's supposed to be, largely it's supposed to be review for us. So the way that I taught you, we've been using the idea of indefinite integrals and treating those guys as antiderivatives. So you guys are already well prepared for this. In other words, anytime I write some symbol that looks like this means find the antiderivative of little f. So what we're basically saying is if you took the derivative of capital F of x, you're going to get the inside thing, little f of x. Okay. So we've been working a lot with this type of question. And in fact, our quiz on Wednesday is all about antiderivatives. So you definitely want to practice that. Now, example 1 is not asking you to find an antiderivative. Example 1 is asking us to verify that this object here is the antiderivative of this inside thing. So how are we going to verify that this is the antiderivative of this? Does anybody have any suggestions for me? How do I verify that the right-hand side is the antiderivative of the inside here? Any thoughts? That is correct, Luciano. I knew if I waited, you'd tell me the correct answer, or someone would, right? So just to make it perfectly clear, this inside part is our little f of x. This is our capital F of x. So we're just going to follow Luciano's advice. We're going to take the derivative of the right-hand side. And to do that, to take the derivative of this first piece right here, I need to use the product rule, right? So the derivative of x is just 1. You keep the second thing, which is sine x, plus the derivative of the second thing is cosine x, and we keep the first thing, which is x. That's the product rule there. Then when we take the derivative of the second term, the derivative of cosine x is negative sine of x, and the derivative of c is just 0. Okay. So what do we see happening? We see that you have a sine x in front and a minus sine x there. So when you just rearrange the terms, you get x cosine of x. And that's the same thing as our little f of x. So we've really just used the definition of what an antiderivative is to verify that this guy is the antiderivative of that guy. Sorry, I don't want to prime there. That's f. And then I'm going to calculate the derivative, f prime. Does that make sense? Terry, do you know how to do the product rule? What's the product rule? Oh, right, we're using the product rule on this guy. Oh, shit. So you're taking the derivative of the second thing. The derivative of the second thing is cosine of x. And you keep the first thing, which is x. Yeah, no problem. Okay. Example 2 is asking us to find the antiderivative. When I look at the antiderivative of this guy, this is not one of the common trig antiderivatives that I'm familiar with. So I really need to change the way this inside part looks. So I need to change the way this looks. Okay. So how am I going to change the way that guy looks? I probably want to use a trig identity. So it turns out that cotangent of x has a trig identity called a quotient identity. Does anyone know what the quotient identity of cotangent of x is? On the top, it's going to be cosine of x, and on the bottom, it's going to be sine of x. So this guy is really the reciprocal of the tangent one. So tangent of x is equal to sine x over cosine of x. And then cotangent's the reciprocal of tangent. So then we would just invert the fraction. So once we have this trig identity, these guys are both called quotient identities. Then we can solve this problem because this integral becomes the integral of cosine of x over sine of x times sine of x dx. And then these two guys cancel each other out. And then you're left with just the integral of cosine of x dx. And the antiderivative of cosine of x is sine of x plus c. Is there any questions about this example? Okay. So, actually in this course, you really only learn 2 integration techniques. And then when you take calculus 5b, you're going to learn about another 5. So right now, life is actually pretty good for you because you don't know that much as far as how to integrate. So I'm limited in the types of questions that I could ask you. What are these 2 methods? The first method is what I call change the way it looks. And I did that with a trig identity over here. And the second method is something called integration with substitution. And that's really what 4.5 is about. So today's class, or this week, is really all about integration.